Okay, students, this is not too bad of a lesson, short lesson here. Mod 2, Topic 3, Lesson 3, the last one. All right, so this is the bottom of page 425 is where we're at. You can see right there, it's the last lesson of the topic here. It's dealing with chords and arcs. All right, so what I want you to do first off is to go ahead and pause the video and identify, as it says on number 1 here, write everything you know about this diagram. So you're trying to mark as many things up on here as you possibly can. That's using your congruence, what you know of congruent triangles, everything. Okay? So go ahead and do that, and then when you think you've done as much as you can, then go ahead and hit play again. All right, here we go. So QR is a radius, QP is a radius. So therefore we know they're congruent, which means now I have an isosceles triangle right there, which the very first thing I should think with an isosceles triangle is isosceles triangle theorem, which says base angles are congruent. Well, now that I have base angles congruent, okay, now I can see that triangle QPS is congruent to triangle QRS by what? AAS. Angle, side. Okay. Now we know those are congruent. Remember, after proving triangle is congruent, I can state any other piece, corresponding piece is congruent by what again? Let's see if you can get it before I write it down. So therefore we know segment PS is congruent to segment RS, and QS is congruent to QS, and angle PQS, is congruent to angle RQS, all by CPCTC. So once we've proven the two triangles congruent, remember we can say any other of the corresponding parts are congruent. Since I've already used 1. Now I could have got QS congruent to QS by itself by reflexive property. But since I had already proven the triangle is congruent by AAS, I could just go ahead and use the CPCTC there as well. But I could use reflexive property. That should be your free piece that you could be looking for. Okay. Then you could use, if you identified the QS first already, you'd also have HL theorem that you could have said, or AAS. Okay. For the two triangles being congruent. Now, the other piece that we don't have listed here is this line right here. So we can call that line QS, because there's 2 points on it, is a what? What's it called? When it goes through a circle twice, it's called a secant. Oops, secant. All right, so that is all your information listed there. Okay, review. Okay, so now, as it says, go to the bottom of 428. And go ahead on your theorems page. Take out your theorems pages and write all this down on theorems. The diameter chord theorem. Write that down, and then I'm going to draw a picture of it. If you want to write down this definition on there, you can, but obviously we know a picture's worth 1,000 words. So it says if a circle's diameter, so I have a circle here, and if it's diameter, remember diameter has to go through the center, the longest chord of the circle, you should remember that. If this circle's diameter is perpendicular to a chord, so now I go ahead and put any chord in, and it's perpendicular to that chord. Boom, now it's perpendicular to the chord. That's the given. Remember, the if part is the given. So if the diameter's circle's diameter is perpendicular to the chord, then here's my conclusion. Then the diameter, that diameter, bisects the chord, so that means that has to be congruent, and bisects the arc determined by the chord. So now that arc equals that arc, whatever that measure is. Okay, so that's called the diameter chord theorem. So at least write down the name of it and draw that picture. Okay, now go ahead, once you've done that, and go to the bottom of 430. We have the equidistant chord theorem. So again, write down the name of the theorem on your vocab sheet, and here's the drawing off to the side here. If two chords, remember a chord is any segment that has its endpoints on the circle, and two chords of the same circle, I'm just drawing the same circle here, or I could have had a congruent circles are congruent. Now, I went ahead and put the arc, show that they're congruent over here. We could put it on both sides to see the whole length is the same. Okay, I'll make it clear. So if two chords, that chord and that chord, if two chords of the same circle or are congruent. So if those two, the green and the blue chords, are congruent, then they're equidistant from the center. So I put it, there's my center. I showed they're equidistant. Now when we're talking about distance, distance is always at a perpendicular. Okay, it's never at an other than 90 degrees. Shortest distance between any 2 points is the perpendicular distance. Okay, so now you're able to say that those distances to the center of the circle from the chord are equidistant. That's what this is saying. Now notice we're going to talk about the converse. The converse, remember, that means to switch the if and the then. So that's what the next one will be. If we know, I'll just say it here before we turn to it. If we know that this is true, so now we switch it and say if that's true, if two chords are equidistant from the center, then those chords must be of equal length. We switch in the if and then. So that's what we see on the next page, bottom of 431. If two chords of the same circle are equidistant from the center, that's all I done is switch it. So I draw a circle, have my center, here's a chord, here's a chord. Remember, the distance is always at a right angle. So it's saying if that distance equals that distance, and the length of that chord must be the exact same length as that chord. That's what it's saying. The equidistant chord converse theorem. Okay, so draw that. Once you've got that down, go to 433, the bottom of 433. Now we have the congruent chord, congruent arc theorem. So if you just think about that, if I have a congruent chord, it's saying I'm going to have a congruent arc, just from the name of it. So if two chords of the same circle are congruent, circles are congruent. So here's a chord, and here's a chord. If those are congruent, so the red is the given, or the if part's the given, the then part is the conclusion. Okay, so if those two chords are of equal length, then their corresponding arcs, that arc must be congruent to that arc. That's, say, 100 degrees, and this must be 100 degrees. Same arc measure. Okay, so if that chord length is 10 and this is 10, then whatever that arc measure is, it must be the same as that arc measure. Okay, now go to the bottom of 434. We have congruent chord, congruent arc, converse. So now we just switch the order. Okay, so now if we're given that the arcs are congruent, so the green is true, the given is the green, as it says right here, green is given, the results is the red. So if the arcs If two arcs are of chords are congruent, then the length of those chords also must be. They don't have to be parallel, by the way. I'm just sort of drawing that looks like they're parallel. But I mean, it could be, I could have another one right here. Let's say I say that right there. And I'm saying that that arc measure from there to there is the same as these ones. Then that means that that chord is also the same length. So don't think they have to be like parallel. They don't have to be. They can be oblique to one another. Okay. Okay, that is the gist of this lesson. Okay, here, if you want to practice matching them with their name to their definition, you can do that right now, right there. Otherwise, you can go ahead and work on Mathia, or if you're struggling with your warm-ups, this should be a time to also come up and ask about your warm-ups again, to make sure you get that down. If you're done with your Mathia already for the topic, then you should be watching the video lesson on, I'll be handing out the practice test, the 20 multiple choice practice test. That'll be your assignment to work on. And if you end up finishing that, and I haven't sent out the video answers to the practice test or the video to the review of the topic here, then ask me to send that to you, and then you can go ahead and watch that. Okay, that will do.